Charging and discharging of a capacitor, which is our experiment number 4, will be performing that using MATLAB. So we'll just launch the MATLAB software. We'll be designing a series RC circuit using a MATLAB, and for that this is a command prompt that you'll get. On the command prompt, you have to type down your first command, which is opening of a library window which is called as power library. So you have to just type down power lib power library, press enter, which will open the power library window. This library window is used to create different circuits. For that you have to go to the files menu and click new model. Now this is a new box which is open. In this particular window you have to design your circuit, which is a series RC circuit. So for that you will go to the electrical sources and select the DC voltage source. So while selecting DC voltage source, if you click on DC voltage source and try to drag it, you will not be able to drag the keys, the particular component. You have to click on the symbol and then drag it to this particular window. Then close this window and go to the elements tab and select RLC branch, because we want two elements, which one is R and second is C. So you have to drag this particular block twice, or you can also copy and paste the same block in this particular window. Then you can close the elements window over here. Then you go to the measurements block, because we want to measure current and voltage. We want to measure the see the waveforms of current and voltage. So take the current measurement block over here and also the voltage measurement block. You can close the measurement window, and then you need to double click the RLC branch. Select the branch type as resistance. Select the resistance as 1 mega ohm. For that you'll have to write down 1 E6, which will be 1 into 10 raised to 6 ohms. There is 1 mega ohm. In measurement blocks you have to select branch current, because we'll be measuring the branch current over here. Click apply and OK. Similarly, for the second branch you have to select capacitor. The capacitor's value is 1 e minus 6, that is 1 into 10 raised to minus 6 farad, which is what we want, 1 microfarad. Set initial capacitor voltage to 0 volts and measurements to branch voltage. Click apply and OK. Then you can rotate this particular block in anti-clockwise direction using the rotate menu, and then you also have to include one block which is a power GUI block, which is used for simulation. Next thing is we'll connect all these particular blocks. So you just do a connection from DC voltage source to current measurement block, from current measurement block to the RLC branch, from RLC branch to the capacitor, and capacitor back to the DC voltage. Maybe we can just rearrange this so that it looks aesthetically, it looks pleasing. And then you have to connect the voltage measurement block across the capacitor. So you have to take a connector from here, connect it to this, which will measure the voltage across the capacitor, like so. And that is it as far as the connections are done. Now we want to see these particular waveforms, so you require an oscilloscope. So we'll get an oscilloscope in the view tab, then you go to library browser, and in library browser you need to search for a scope. In search item, type down scope, click enter. It will give you the different types of scopes. We'll select the scope, the first one, and then you can create a copy of that, because you won't need two scope, one for current measurement, other for voltage measurement. Once that is done, you can close this, and then you can connect the scope one to current measurement. What this says is that if you want to quickly connect the blocks, you can select the source block and then hold on control key by clicking the destination block, so directly connections can be done. So what it says is that you select this particular block, then click control click shift and hold control key and click the destination box, which will do the connection. Okay, so this connection can be done automatically. This is what it says. Either way, you have to do all these connections. Once the connections are done, then you just check whether the voltage source is at 100 volts, which is there, so you do not change it, and then click this run simulation button. Now you can see a ready being displayed over here. That means simulation is completed. So now you can double click the scope to see the waveforms. Once this you open this scope window, you go to auto scale, which is the binocular symbol that you have, and then click it, which will show you the graph of current versus time. Similarly, you can double click the other oscilloscope, again go to auto scale, and it will show you the voltage waveform. So this is what is to be done. You need to take the readings of both the values. To take the readings, say, so for t equal to 1, what is the value of voltage? So you just click over here, so it will automatically zoom. So at 1 the voltage is, you can just go on clicking, and just okay. So on 1 the voltage is about 63.25, 63.2. Okay, so this is the voltage. So you can zoom the particular area. So at t equal to 1, the voltage is about 63.2. So you can note down such type of readings. Again, go back to using auto scale, and you can zoom in for some different values and note down the readings. So once the readings are noted down, then you can draw the graphs or do the remaining calculations. You can fill in the table of time, then voltage across capacitors, and you can also find the calculated value using the formula VC, that is voltage across capacitor is equal to V into bracket 1 minus e raised to minus T by RC. Okay, so this is how you need to perform the practical. This is the fourth practical. Thank you.